All right, so let's talk about the periodic table and how it relates to reactivity. Again, we talked about this a little bit yesterday. We talked about the groups and how the groups are related to the reactivity of an element. Remember, the group is a column that shares the same number of valence electrons, and that atoms in the same group have the same characteristics. So let's look at our periodic table right here. This periodic table does not have the group numbers on top, but you have the group numbers on your periodic table which you have at your desk. So remember that this is group 1, this is group 2. The transition metals, we've kind of just labeled 3. This is 3, 4, 5, 6, 7, and 8, which is the noble gases. These things on this side are very reactive. They react. Things on this side are cool. They don't really react much. So the things in group 1 are very, very reactive. The reason they're very reactive is because they only have one valence electron. So remember that you can use the periodic table and you can use this little group number to determine the number of valence electrons in your element. So if I want to know the number of valence electrons in rubidium, I look at the number on top, it's 1. If I want to know the number of valence electrons in germanium, I look at the number on top, it's 4. If I want to know the number of valence electrons in astatine, I look at the top, it's 7. If I want to know the valence electrons in thallium, I look to the top, it's 3. Transition metals are a little bit weird. That's these guys. For 8th grade, we're not going to worry about it because remember that their valence electrons kind of shift around a little bit. So some things to keep in mind about periodic table and reactivity. Reactivity is based on the number of valence electrons an element has. Valence electrons are the outsidemost electrons in an atom. We can look at the table to find the number of valence electrons. We look for the group number, the number on top. And elements in the same group share the same properties. Those are things that you need to write down and you need to keep in mind. They should be in the Cornell notes. If for some reason I've forgotten them, write them down anyway. Reactivity is based on the number of valence electrons that an element has. So oxygen, remember, over here in group 6, is kind of reactive. It actually reacts with metals. It will take the electrons from those metals. It's reactive. Is it as reactive as beryllium? No, it's not, because beryllium has 2 valence electrons, making it much more reactive than oxygen, which has 6. Remember that the closer you get to 8, the less reactive things are. Valence electrons are the outsidemost electrons in an atom, and you can look at the table to find the number of valence electrons. You just look at the group number, which I've written on here in red. Also, and it's vital, and we'll talk about this in the next slide, elements in the same group share the same properties. So looking at this blown up part of the periodic table, if I asked you which element is most like silver, what would you tell me? Is it A, nickel, B, gold, C, zinc, or D, cadmium? The answer is obviously B, gold. Atoms in the same column share characteristics. So copper, silver, and gold all have very similar characteristics. They both have about the same rates of conductivity. They are about the same rate of reactivity. They oxidize about the same way. They all have very common properties. If I asked you which is most like lead, is it A, thallium, B, bismuth, C, germanium, or D, antimony? Again, the answer is C, germanium. Germanium is most like lead because they're in the same column. Elements in the same column share characteristics. This is a question that often comes up on STAR, and it's one that you really need to be familiar with. So again, elements in the same column share characteristics. You're going to do some activities today and moving forward that have to do with arranging items in a table based on their shared characteristics. That's something that seems pretty common sense. If I had a table that was arranging different types of animals, I'd probably put all the reptiles together in one column, all the mammals in one column, all the insects in one column, all the birds in one column. You can think of it that way. Think of each element as fitting into a specific family. That's why these columns are different colors, because they have different families. So again, elements in the same column share the same characteristics.